Okay, happy Sabbath, guys. This video is on the brain and behavior. The test will be due. Let's make it next week Saturday. Okay, I'll load another video before then. But I want to do that at your own pace. But take a week at most to do the test. So we're trying to have a pace, you know. If we get this done, we can still continue some book work. So by the time club opens again, everything will be good. Okay. So brain and behavior. Your first point. You should be able to label a diagram or a model of the human brain, including the following parts, and tell briefly what each part does. Okay, so briefly people on the main parts. So the first part is, that I want you to know is the medulla for sure. The medulla, as you can see, is that part here, and it controls autonomic functions like breathing, your heartbeat, and you don't have to think about it. You know, you don't have to think about your heartbeat for your heart to beat. It also controls peristalsis. It helps your skin regulate your body temperature, all that kind of stuff. Okay, and then the main part of the brain is the cerebellum, and the cerebellum controls balance, posture, this kind of stuff. And you should also note that in alcoholics or people who drink a lot of alcohol, it damages the cerebellum. And what happens is that even if they're not intoxicated, they will still have a kind of staggered walk because the alcohol will have damaged cerebellum to such an extent. Okay. Hypothalamus. Okay. So let's read this. It links the nervous system to the endocrine system by stimulating the secretion of hormones from the pituitary gland. It controls our emotions, body temperature, hunger, thirst, fatigue, and circadian cycles. Okay, so what I want you to know is that it links the nervous system to the endocrine system by stimulating the secretion of hormones from the pituitary gland. That's what you have to know. Okay, that's really what you have to know. So the pituitary gland, we just spoke about it a while ago. It secretes hormones regulating a wide variety of bodily activities, including hormones that stimulate other endocrine glands. Okay, the pituitary gland helps control growth, blood pressure, sex organ functions in both men and women, and the conversion of food into energy, your metabolic rate, and temperature regulation. Okay, so the pituitary gland can be broken up into two parts: the anterior pituitary gland and the posterior pituitary gland. The posterior only releases ADH, antidiuretic hormone, which leads your body to absorb more water in the kidneys before your pee comes out or your urine comes out. It also releases oxytocin, okay, which is the pregnancy hormone, just for the pituitary gland. All the other hormones that the pituitary gland releases comes from the anterior pituitary gland, which is in the front. And that an example of this would be growth hormone. Too much of which can lead to giantism. If you have too little, it can lead to dwarfism. There are other reasons for dwarfism. Achondroplasia is another reason why somebody can end up having dwarfism. I think I put that with one of your tests in your previous test. It also releases TSH, which is thyroid stimulating hormone. Your thyroid has to release thyroxine to regulate your metabolic rate, helps in body development, sexual development, all that stuff. So it releases basically if your thyroxine level is too low, receptors will tell the pituitary gland, well, this guy doesn't have enough thyroxine. So the pituitary gland release TSH to stimulate the thyroid to release thyroxine. So it's a cycle, okay? And that's why the pituitary gland is also called the master gland. Next, the cerebrum. It's where thinking occurs. This is the area of the brain responsible for language, memory, and emotion, as well as motor control and your sense of smell. Okay, so I want to look at this diagram first. In the frontal area here, okay, this is the part of your brain, or the part that will be covered by, let's say, the frontal bone, can we on the scale, the frontal bone. It controls decision making, planning, problem solving, conscious thought, intelligence, emotion. Okay, now a bigger forehead does not mean that you are smarter. That has to do with your skull and the shape, not the actual size of your brain. Okay, guys, and it's also an important reason why um your parents or adults would advise you to, I don't want to make them professional, but you don't want to like have a girlfriend, all that kind of stuff when you're supposed to be in school. Because the point is, when you, at your age, your brain is not developed enough to handle the front part of your brain that controls emotion, intelligence, conscious thought, problem solving, planning, and decision making is not developed enough to handle all these things at once. Okay, it literally cannot manage it. So you think you're making a good decision, and you probably is to the best of your ability a good decision, but it may not be. Okay. The side here would control memory, speech, language, hearing. There's Wernicke's area and Broca's area around that region. Um, Broca's area allows, gives you ability to form speech, and Wernicke's area is your ability to comprehend speech. Okay. Um, on the top here, you have your motor and sensory. Okay, your motor and sensory areas. So they have neurons that would send impulse, that would get impulses, sorry, from receptors in your body, like your ears and stuff like that. Sorry, not your ears, like on your hands when you touch something. You have nerves that can sense pressure and temperature. So it would send an impulse to the sensory part, it would relay to a motor part. The motor part would be somewhere behind it or something. And then the motor part would send an impulse to your hand, which is the or muscles in your hand, which is the effector, and pull your hand back. Okay? So there's a receptor, the sensory neuron. The receptor sends a message. It goes to the sensory neuron, goes to a relay neuron. The relay neuron sends it to a motor neuron. The motor neuron is attached to a muscle or gland or something, and that the part, the gland or muscle that the motor neuron is attached to is what's going to respond to the whatever the stimulus is. Okay, right. So what is I've spoken about neuron, but what is a neuron? Okay, draw a picture of a typical neuron and label its parts. Where does information from a neuron and where does information enter a neuron, and where does information leave? So this diagram specifically is not actually the type of neuron that you will see, but it's a diagram that has all the basic parts of a neuron. Okay, so of course we have the dendrites, which can also be called the dentrons, and they basically bring an impulse towards the cell body. Okay, so anything that's bringing an impulse towards the cell body is called a dendron or dendrite. The cell body is here, it can also be called the soma. It'll control the nucleus, the cytoplasm, all the normal things in a cell. Okay, and then we have the axon. The axon carries the impulse away from the cell body. Okay, no matter what you're looking at, the axon carries it away from the cell body. The dendron or dendrite carries it towards the cell body. All right. So the axon is protected by a myelin sheath. Right? I don't know if I'm pronouncing that S word right, but I never get it right. Um, but it's basically a layer of fatty acids and stuff like that that basically insulates the axon so that the the integrity of the impulse is not lost to the environment as it travels along the axon, and also to speed up the rate at which the impulse travels along. Because you want your reflexes to be fast, right? Now what happens, as you can see, there are little spaces in between the myelin sheath bundles, and these are called the nodes of Ranvier. And the impulse basically, like I was saying, is supposed to protect. If this is supposed to protect the impulse, why would there be spaces? Okay, but actually, the God designed the neuron so beautifully that this actually helps and speeds up the rate at which the um, impulse travels along. So what happens is that the impulse basically leapfrogs from this myelin sheath bundle to this one, to this one. So it passes, leaps along that gap to get there. Passes, leaps along that gap to get there. And that leap is called that is done by saltatory conduction. Okay, saltatory conduction. So the Schwann's cell as a type, well, the cells that make up the myelin sheath, that's one of them. Okay, you have to know about that. The axon terminal. So it's called the terminal buds or the synaptic knobs. And basically, between two there's spaces between two neurons, and that space is called a synapse, right? And the synapse, the impulse cannot travel between the synapse. So what happens is that the vesicles, the smaller branches there, release something called a neurotransmitter, which is a chemical which carries the impulse from one neuron to another. That's what happens, okay? Along the synapse. Now, explain how drugs affect the function of the neurons, especially at the synapse. Make a commitment to never take drugs except for medical reasons. Let's read what they have to say. Axons carry electric signals from a neuron to the dendrite of another neuron. Oh, I forgot to say this. Right. So what happens is I want you to think of a chain of these things, a chain of them, multiple, lined up with each other. This part, this purple part, will always match up to one of those red part kind of things. Okay? So it always be a dendrite to axon. So if the dendrite comes here, then the next part will be, if the dendrite, let's say another one of these that was linked right here, right? The dendrite would be here, so it would have an axon on the other side. You know what I'm saying? I picked up, let me see if I can draw this so you can see. So right here, there'll be an axon here. At this point of the next neuron, at the end of that neuron will be the dendrite. So then that means that the next end, the next neuron, this is one neuron. So the other neuron connected to this neuron would have to have an axon here, right? And a dendrite here. Okay? And this would be the synapse, the space between. Okay? So it's like a map. So the one that would have to be, the next neuron would have to be attached there, would have to be this is the axon, end of the axon, would have to be a dendrite. Okay? I think you guys can picture that. Alright, let's go. However, an axon cannot transmit its signals directly to a dendrite. It needs a synapse to do this. The synapse converts the electrical impulse to a chemical reaction, which releases different types of chemicals called neurotransmitters, like I explained. These neurotransmitters travel along the synapse and cause other chemical reactions to generate electricity in the dendrite. Okay, so let's think of that as converting the impulse. I didn't want to burden all the explanation and all stuff. The synapse can be trained to react strongly, weakly, or anywhere in between, or not at all. It is because they can adapt when we are not able, sorry, it is because they can adapt that we are able to learn new things, form habits, good or bad, or suffer from addictions. Many drugs affect the way the synapse does its job by preventing the neurotransmitter chemicals from traveling along the synapse. Drugs can also amplify these reactions so they are more intense than they have been in the absence of the drug. Okay, that's why you crave it. That's what they're trying to explain here, I think. So I want you guys to make a commitment to not take drugs ever unless it's for medical reasons. Okay? So what is a reflex? We've spoken about the knee-jerk reflex before. But let's see what they have to say here. Instructions. Gently tap someone just below the kneecap while the person's leg is hanging over the edge of a chair. A simple reflex is entirely autonomic and involves no learning, right? An example is the escape reflex, the sudden withdrawal of a hand in response to a painful stimulus, or the patellar reflex, the jerking of a leg when the kneecap is tapped. Sensory neurons in the body stimulated with sensory neurons in the stimulated body part sends a signal to the spinal cord. Within the spinal cord, a reflex arc switches the signal straight back to the muscle of the body. In the case of the arm or the leg, to a motor neuron. Contraction of the muscle occurs and only three nerve cells are involved, and the brain is only aware of the response after it has taken place. So basically, I've explained this before. There is a patellar tendon under your kneecap. If you hit it, That will send an impulse along a sensory neuron to your spine. It's called a spinal reflex. It only involves your spine, your brain will not know. It sends the impulse through a sensory neuron to your spine. There's a relay neuron in your spine that will send the impulse to a motor neuron. The motor neuron goes back to the extensor muscle in your thigh, right? And it will cause it to flex and your leg will go up, right? What is a sensory neuron and what is adaptation? Sensory neurons are nerve cells within the nervous system responsible for converting external stimuli from the organism's environment into internal electrical impulses. For example, some sensory neurons respond to tactile stimuli and can activate motor neurons in order to achieve muscle contraction. Such connections between sensory and motor neurons underlying motor reflex loops and several forms of involuntary behavior, including pain avoidance. Right? In humans, such reflex circuits are commonly located in the spinal cord. Neural adaptation is a change over time in the responsiveness of the sensory system to a constant stimulus. It is usually experienced as a change in the stimulus. For example, if you rest your hand on a table, you immediately feel the table surface on your hand. Within a few seconds, however, you cease to feel the table surface. The sensory neurons stimulated by the table surface respond immediately, but then respond less and less until they may not respond at all. This is called neural adaptation. Okay, so sensory neurons, like I said, yes, they convert the external stimuli into electrical impulses. They are pressure sensors, temperature sensors, all kind of nerves in your skin that can sense all kind of stuff and send the impulse to your brain and spinal cord, which leads to a reflex. Okay. Of course, pain avoidance is one of those things. Touch something hot, the nerves in your skin that can sense temperature will send an impulse along a sensory neuron in a relay neuron to a motor neuron in your arm that will pull your hand back. Okay. Now, neural adaptation. What they basically say is you can get used to something. That's what they basically say. Okay? You will respond less and less to something over time. Now, what they want to say, what is the spiritual lesson that can be drawn from the concept of adaptation? Just as a sensory system can adapt to a stimulus until we no longer even notice it, we can adapt to a sinful environment until we no longer notice the sin. The conscience, becomes numbed when ignored. We must be careful about the sorts of stimuli we allow ourselves to be subject to. Watching television programs that promote sin will dull our senses to the enormous level of sin, just as the constant stimulus to the skin will dull our perception to it. A common example of this is that when you were in primary school, there would always be a one child or something that would say they cannot feel licks. Like the mother beat them or whatever. It's like, well, my mother just beat me. I get used to that already. Right? This, like it or not, that's an example of the neural adaptation. We say the skin get thick and stuff like that. And of course, it could be a part where the conified layer, the first layer of the skin, of the epidermis, becomes thick. But the fact that it became so thick that they don't feel it, no. It's a situation where they've just got used to the pain. They've numbed it out. They want to do something, they'll do it even if it gets the pain, even if they get the pain. Okay? We must not be this way when it comes to our spiritual life and our relationship with God. Do something wrong? Okay, learn from it. Do not just continue to do it, because if you continue to do it, of course, like they said, it will be numb. You will just do it without thought, your conscience will go numb. Okay? Next point. How are the senses of taste and smell similar, and how are they different? Both the sense of taste and of smell detect chemical compositions of substances through chemoreceptors. Okay? Taste is detected by the tongue in solids and in liquids, while smell is detected by the nose in airborne substances. There is much debate in the scientific community as to whether the taste map is a real phenomenon or not. So that's basically when they say that different parts of the tongue can taste stuff better. I can't remember exactly what it is because I don't believe in it. But the parts of your tongue, like you put something that's like you taste sweet or kind of stuff like that. Okay. Those who espouse the theory say that sweetness is best detected at the tip of the tongue. Oh, okay. So they say it there. Bitterness at the back of the tongue, saltiness at the sides of the tongue, and sourness further back along the sides of the tongue. Those who dismiss the theory say that each of these sense of taste can be detected on all regions of the tongue, and that the taste map is basically on a misinterpretation of a German medical paper by a Harvard psychology student in 1901. Try the experiment yourself outlined in the requirement and draw your own conclusions. So you guys can try this out. Um, this part might not come on your test. It should. It will come on your test. Yeah. Next, draw a picture of the various pictures. Wait. Draw a picture of the various parts of the eye and explain why you have a blind spot. Find your blind spot for one eye. Okay. So the main parts. There are three main parts. There's the sclera, sorry, or sclerotic coat. You have your choroid, and you have your retina. So your sclera forms the cornea. This diagram is really difficult to read. I think this is your conjunctiva. I think that's what they're trying to show there. So this is your cornea. Okay, I guess number 5 will be your cornea. Um, this part here, this colored part is the blood vessels. This is your choroid, and it goes on to form the ciliary muscle, right? The ciliary muscle is here and here. This is your suspensory ligaments. Number 2 will be your suspensory ligaments, and they hold the lens of your eye. Number 1 is the lens. So what happens is that when they flex, the lens becomes super thick and super convex, which can lead to which helps you read stuff that are close to you. Like if you're reading a book, that's what happens. So the ciliary muscles flex, the eye becomes more convex, and it can bend the light rays entering your eye from the book so that it forms the image on your retina. If you're looking at something far away, like if you're looking at a ship on the horizon, what will happen is that the muscles would relax. So they would just relax, they'll shorten. Sorry, they would shorten. They relax. It pulls on the suspensory ligaments, right? And it causes the lens to stretch and become thin. That's because light from a far away from thing like, let's say, the ship on the horizon, like I said, the rays have traveled such a distance that they can be considered to be parallel to each other, and therefore you don't really have to bend the light rays. Okay, so a thin lens will do, and the image will form on the retina. If the lens is really thick and the images and the light coming into it is already basically parallel, okay, the image will not form on the retina, and that can go to I don't know if you have to do eye defects there. No, you don't. Okay, so you don't. Now, next layer, the retina. The retina has photoreceptor cells, the rods and the cones. The rods is for dim light, black and white vision. It's more towards the outskirts of the retina, around here. And then you have the cones, which is for colored vision, more towards the center here. And you have the fovea here, or the yellow spot, which is a collection of cones for colored vision. And your blind spot would be here. Your blind spot is where the optic nerve is connected to the eye, because there are no photoreceptors here. So it's blind, you cannot see. Okay? If the ray of light were to come here and form an image here, you would not see. Right. The parts of the air. Okay, so there's a lot of stuff you have to understand, but basically the sound comes here, right? You want it to basically catch the sound. It travels along this inner part here, and the whole point is to stimulate this part. Okay, that's the whole point of just to stimulate that part so you hear it. Okay, the air is a very special thing. It works based on a logarithmic scale, so that large increases in temperature would lead to small increases in the actual sound that you hear. Okay, and this is what you have to know. Causes of hearing loss. Listening to a Walkman. Okay, so you can see this is made a long time ago. Listening to loud music in your ear is what they're trying to say. Okay, personal electronic audio devices such as the Walkmans and iPods. Wow, long time ago. Often reach 150 decibels or higher. Can produce powerful enough sound to cause significant no noise-induced hearing loss, even though lesser intensities of even 70 decibels can also cause hearing loss. So if 70 decibels can cause hearing loss, and this thing can go up to 115. Okay, I know none of you have iPods because that was a long time ago, but I'm pretty sure our phones and our headphones can do the same thing. So just they work. Next, putting something long in your ear. That's like can't remember the name for it. The thing people put in the cotton buds. I haven't used that in a long time because when I read about that some years ago, I just stopped. But it's the thing that goes in your ear to clean your ear and stuff like that. Right, that can lead to damage. Um, Being in the front row at a loud music concert, that's basically the illusion life. Try to avoid that, people. Not treating an ear infection properly. Remember, if you have something, go to the doctor. Okay, doctors are your friends, trying to help you out. Standing behind a jet at an airport. Right, that can boost your eardrum. That's common knowledge. Right, number 9. Do one of the following activities. Watch a lie detector test being performed. Observe an MRI being performed and explain what information can be learned from the test. Observe a neuron under a microscope. Okay, so I basically explained how the neuron looks. I've explained the neuron really well and the brain. So that should be enough. Okay. List 5 things that you can do to protect your brain from damage. Okay, number 1, wear a helmet. Many work and recreational activities can subject a person to head injury. It is best to not take chances. Wear a helmet when it's called for. Do not enter a hard hat area without a helmet. Put on your helmet every time you ride a bike, go rock climbing, play football, or paddle a kayak. Why risk it? That makes sense. Exercise your brain. The more you use it, the better it works. The saying "practice makes perfect" is very true, and any activity that involves the brain can be improved with practice. Get plenty of air, your brain needs oxygen, that is true. Say no to drugs. Most of the illegal street drugs are popular because they affect the way people feel. The only way they can do this is by affecting the brain, and these effects are never harmless. Drugs can do permanent damage to the brain. And finally, eat healthy foods. Junk foods cloud the brain. Healthy foods are just as good for the brain as they are for the body. Okay, so do one of the following. Visit and care for someone minimum of 2 hours who has a disease of the brain and report on their special needs. Okay, so we'll read about one of them. Let's read about quadriplegic and paraplegic. Okay, the quadriplegic is a symptom in which a person experiences partial or complete paralysis from the neck down. It is caused by damage to the brain and to the spinal cord at a high level. The injury causes the victim to lose total or partial use of the arms and legs. Okay, so paraplegic is a condition in which the lower part of the patient's body is paralyzed and cannot move. It is usually the result of a spinal cord injury or congenital disease such as spina bifida. Okay, spina bifida is basically when the spinal cord of a child it basically grows in 2 pieces that is not connected. So that leads to the child being paralyzed. Okay, it's not normally a thing that I think we see in adults. I think it's more children where the spinal cord doesn't develop properly. Okay, Find at least three references from the Bible that refer to your brain and or to decisions that you make in your life. Okay, so we have Luke 14, Matthew 4, Mark 8, Matthew 16, 2 Corinthians 7 verse 1, 1 Peter chapter 1 verse 13 to 16, and 1 Thessalonians chapter 4 verse 3 to 8. So we are done. We have one more official honor. Hope you guys really enjoy this. Learn from as much as you can. Um, the master honor can be yours. Remember that. Bye, guys.